So 2D.4 lets us allow to define positive definite and negative definite quadratics. So let's have a look. We know that the discriminant is b squared take 4ac. So that's going to tell us a couple of things. If we have used discriminant to determine the number of real roots of the equation, so the options are, if we just quickly run through them, if it's greater than 0, there's 2 real roots. If it equals to 0, there's 1 real root. And if it's less than 0, it's going to be no real solutions. No real roots, I guess. If they exist, these roots correspond to zeros of the quadratic. Discriminant therefore tells us about the relationship between the graph of the quadratic function and the x-axis, because it's telling us how many times it cuts the x-axis. So for example, this is 2, this is 1, and this is, let's say, none. So this is all axis symmetry x equals 1. So they have demonstrated the same graph, but they have demonstrated 3 different discriminants. So let's have a look. This one's greater than 0, equal to 0, less than 0. It just looks like this. So this one is located so that it cuts the graph, cuts the x-axis, touches the x-axis, and this one doesn't have any real roots, doesn't have any x-intercepts, but you can still draw a graph. It looks like that. So in order to find that, you need to obviously find the discriminant for both of them. So these are the information you should be able to tell from the graph. Cuts the x-axis twice, touches the x-axis, so be familiar with those languages. Does not cut the x-axis. So for a quadratic function, we consider the discriminant. We already are used to it. So when its discriminant is greater than 0, what it tells us is, it tells us there's 2 real roots, but yes, it also tells us that it cuts the x-axis twice. When it equals to 0, we know that it touches the x-axis, so this is what we can also say. When it is less than 0, it does not cut the x-axis. So these are the things we can also summarize as well. Now, something called a positive definite quadratic is a quadratic which are positive for all values of x. So this is what it looks like. There's our x-axis. It doesn't touch it. And it has a positive graph. A quadratic is positive definite if and only these 2 conditions satisfy. A has to be greater than 0, so it's a concave up graph, and discriminant has to be less than 0, so meaning it does not have any x-intercepts, any roots. Negative definite quadratic looks really similar. X-axis does not cut it, and it's concave downwards, so it looks really similar. One's just going up, one's going down. In order to satisfy this case, it's going to be, so in order to satisfy negative definite, it's going to be when a is less than 0, so it's a concave down, and when also discriminant is less than 0. So just looking at these notes, we can kind of find out that these facts is the same. Our discriminant is always less than 0 because that gives us the fact that no real roots, meaning there's no x-intercept. So that's where that fact comes from. And then the A gives us the concavity, concave up or concave down. So if it's a concave up, it's going to be positive. If it's a negative, it's going to be a concave down. So we know that. That's all you need to kind of consider. So let's have a look at this example. So use the discriminant for this to determine the relationship between the graph of each function and the x-axis. So let's give it a go. My discriminant is going to be b squared 4ac, so I need to first of all identify my a, b, and c. It'll be 1, 3, and 4. Hopefully that's now easy for you. So I get 3 squared, take 4, a, c, 9, take 16. So I get negative 7. So my discriminant is a negative, so my discriminant is less than 0. So this will give me no x-intercepts. Okay, so it'll look something like this, no x-intercept. And we also need to look at the a value. A value is 1, so it's greater than 0. So if I have a look at my notes, it's going to satisfy the positive definite quadratic. So a is greater than 0, discriminant is less than 0. So therefore, positive definite quadratics. So if I draw it, it's going to look something like this. Right, it's not going to touch the x-axis, and it's going to be always positive. That's what it's going to look like. So I've kind of determined the relationship between. So let's have a go at B. So again, same start. B discriminant equals b squared take 4ac. My a is -2, my b is 5, my c is 1. So I get 25 plus 8, 33. So my discriminant is greater than 0, so I have 2 real roots. So it cuts x-axis twice. So, and then my a is -2, so it's less than 0. Therefore, concave down graph. So if I draw that, it'll look something like this. This is the x-axis. It'll look something like this. Concave down, it has 2 real roots. So if I just summarize this one again, the A, I should try to summarize it saying no real roots, which is the same thing as that. And then I guess I can write therefore concave up graph as well. That's everything.